Hello there, viewers of this video. This is the Yashica YC25 reel-to-reel tape recorder. This is a very interesting machine incorporating a rim drive system. The speed starting out is slower than 1 7/8, probably close to 15/16 inches per second. Being a rim drive unit, the speed is a bit faster toward the end of the tape, probably approximating somewhere close to 3 3/4 inches per second. I hope you enjoy the following presentation.
Hello there, viewers of this video. This is the Yashica YC25 reel-to-reel tape recorder. This is a very interesting machine incorporating a rim drive system. The speed starting out is slower than 1 7/8, probably close to 15/16 inches per second.
Looks like it runs halfway between 15/16 and 1 7/8.
A rim drive unit, the speed is a bit faster toward the end of the tape, probably approximating somewhere close to 3 3/4 inches per second. I hope you enjoy the following presentation.
A little bit fast, or it runs a little bit slower than 3 3/4, but not much slower than 3 3/4 toward the end of the tape. We're going to have inside shots of this unit. I hope you enjoy it. We'll take a trip back in time for the actual presentation, because the introduction stuff was actually shot after the earlier parts of the video, which are actually shown later in the video. What the hey? The mechanism to switch between record, play, rewind, and stop may get stuck, where you might, for instance, push the play button and play stays down when you press stop, and it gets kind of annoying. Well, lubrication's pretty simple. I'm using LLOYDS graphite lock fluid. This stuff helps out with lubricating that switch. Take a look. Here is the Yashica YC25 reel-to-reel tape recorder portable. Here is the switch. The switches between the different functions. This switch will be lubricated. I've already lubricated the record and the play buttons, but I will go ahead and lubricate the rewind and stop button. I put it into that mode so this little rod points outward. Then I very gently press on the pusher gently so I can control the amount of flow that comes out, so it's not too intense and too much at once. Then I switch to the next mode. Stop in this case, which stays pressed downward to keep the drive mechanism from touching any other rubber surfaces. And then once all 4 of the pieces of the switch mechanism are lubricated, we'll keep the recorder upside down and we'll work through the different functions so that the lube has a good chance of kind of working its way into the mechanism. With the recorder set on its side, we're also going to put some lube into the vertical part of the mechanism that goes into it long ways. The contacts, electrical contacts, are all on the outside of this switch, so this lube should not mess with any of them. Once we have the lube, we'll let it kind of sit in there for a moment, work its way down, and then we'll start moving the mechanism between different functions to pull that switch in and out. Okay, it's rewind and play that move it back and forth, so those are the ones we're going to be engaging to help work the lube. Okay, that should result in better performance. Now we should be able to shuttle between the different functions with ease. Play, stop, rewind, stop, record, stop, play, record, rewind, play, rewind, record, stop. You can go between any of the functions straight to another. You don't have to press stop before pressing rewind. You can go between play and rewind just like that if you want to. Doesn't hurt anything. This is a very interesting tape recorder. I recapped the amplifier on it. All the electrolytics were leaky. One of them was super duper leaky. The other ones were mildly leaky. Well, one of them was kind of okay, but I replaced it. Still. Unfortunately, there is a distortion that happens during record mode, which is a very characteristic sound. This is a DC bias recorder, so you might be thinking I'm talking about your standard DC bias S distortion that you typically get with DC bias. No, that is not the distortion I'm referring to here. It's a very specific sounding distortion that occurs when the bias voltage is not where it should be. It's either too weak or it's too strong. And because of that, you get a certain kind of distortion. You'll notice a lot of the distortion is in the bass frequencies. It's a very unique kind of sound that I recognize. Testing 1, 2, 3. This is a voice recording. The level is very high, but you should still be able to notice the distortion. It's a very unique sound. It's very similar to the sound you get when you have no bias at all. So I suspect that the bias voltage is incorrect if there is any present. I have had another tape recorder in the past that had the same type of distortion. It was a DC bias recorder as well. Had this same strange type of distortion. And it turned out the bias was either too strong or too weak. I don't remember which. So I had to adjust it. And once I adjusted it, was simply just changing a resistor. Changing a resistor value. Once I adjusted the bias voltage, all systems were go. So we're going to measure the bias voltage that this recorder puts out. We're also going to measure the erase voltage. So, well, yeah, we don't want any sound going in on. Well, yeah, we don't want any sound going on there. Bias voltage is 121 millivolts, or 0.121 volts. Erase voltage is probably going to be in the volt range. Yes, 6.45 volts. Probably the voltage straight out of the amplifier batteries goes across the erase head. Let's try to get a reasonable record level. Hello? Hello, 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 hello. This is a reasonable record level according to the level meter, assuming that it is accurate. But you'll notice the distortion is very strong, even at a reasonable level. It also records at a weak level. Now I don't know if the weak level is due to inaccuracy or bias voltage. I suspect it's related to the bias. There is bias on the head, as you could see, but it's either too strong or it's too weak, resulting in distortion.
Hello? Hello, 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 hello. This is a reasonable record level according to the level meter, assuming that it is accurate. But you'll notice the distortion is very strong, even at a reasonable level. It also records at a weak level.
It's also not erasing very well for whatever reason. Perhaps it's the alignment of the erase head. But this is a very interesting recorder indeed. Let's make sure it didn't mess with any of the recordings on the other side of the tape, which were made on a different machine.
Where you recorded some of them to be a little bit off. It's not that big a deal.
We're going to need to clean the drive system. It's not having a very nice amount of torque. I have not done any work on the mechanics. I haven't cleaned any of the rubber surfaces, so the drive is a little bit weaker than it should be. The belt is still good. It's a spring belt. Very interesting mechanism. If you've ever seen a video on the Standard Unicorder 89, which was uploaded on the very last day of 2019, ha ha ha, little did I know how horribly things would go in 2020. This is a Yashicorder 89. It's a very interesting tape recorder. I've made a video of this in the past, and it uses the same mechanism as this recorder. The mechanism is manufactured by COPAL, or COPAL, however you want to pronounce it, C-O-P-A-L. COPAL was a company that made cameras. That's what they were known for mainly, was cameras. They also made alarm clocks that used flip digits. And I do have a cassette recorder made by COPAL as well. But I don't know of any other tape recorders aside from that cassette recorder and the mechanism that's used in these recorders. This mechanism made by COPAL found its way into the Standard Unicorder 89, manufactured by Standard, but also found its way into the Yashica YC25, and I believe YC is Yashicorder. The Yashica Yashicorder 25. But the interesting thing is this. Just like COPAL specialized in cameras, but made the mechanism, Yashica also specialized in cameras. Some of you out there may be familiar with cameras manufactured by Yashica, but I'm not a camera guy, I'm a tape recorder guy. So the first I found about Yashica was this recorder. But then I found through research that Yashica primarily made cameras. Then I found online there was a Yashica YC-300, which is very similar to this recorder, which was called a Yashicorder. And of course there was a Yashica YC25, which I found that out, thankfully, at Google's results showed some old newspaper advertisement. That's how I found out it was made by Yashica, because there is no mention of the actual brand on this recorder anywhere. It's just the YC25. So, which I very much believe is Yashicorder, is what YC stands for here. And, but the mechanisms by COPAL. COPAL mainly made cameras. Yashica mainly made cameras. And then I find online a Yashica camera with a COPAL shutter mechanism. And then I realized, at least for the Yashica camera with a COPAL shutter mechanism, was an example of Yashica using at least some parts manufactured by COPAL in their product. And here is yet another example of a Yashica tape recorder using a COPAL mechanism. Now, it really is a shame that they opted for DC bias in such a basic 4-transistor amplifier, much akin to the cheapy amplifiers you find in most cheap rim drive recorders. Now, this is a rim drive recorder, but it's not your average rim drive recorder because you have a nice, good, high-quality governor-controlled motor. A kind of motor that's more commonly found in capstan-driven recorders. You've got a small, precisely machined flywheel with rubber inlets on the flywheel spindle area and the motor spindle for the metal spring belt to fit in, which is an interesting way of doing things. Instead of using a rubber belt and just going straight to the metal, they had rubber here and then they had a metal belt. So it actually has a flywheel for extra speed stability of this part and the governor to make a constant speed even under load, driving the rim drive of the tape recorder, the take-up reel. And put it into play mode, and that flywheel bends down over and it makes good contact with that. Now, there's not much torque right now because I haven't cleaned it at all. The rubber needs to be cleaned. If I push it down a little bit, there's a whole lot more torque. And then rewind is the same kind of thing. It rocks the other direction, and your little roller goes up against the rewinding, the supply reel there. Here's a better view of the rewinding mechanism in action here. You can see how dirty and gritty the old rubber is there. Thank goodness the take-up reel isn't like that. And then the take-up reel drive, I'm very sorry, I'm so sorry, is right like that. So, quite the tape recorder mechanism. I'm just so intrigued by the build quality of this mechanism, being that it is a rim drive tape recorder. It's just so unusual. Safety. So I've already replaced the caps on the amplifier because they were leaky and it was very weak audio. And safety, I'm going to go ahead and locate the bias resistor, and then we'll be able to adjust the biasing resistor to get optimum sound quality out of recording. Obviously it's not going to sound extremely good most likely, but it should sound better than it currently does. Here's our little circuit board. Kind of cute little guy. I laughed when I opened it up and first saw that board. I was hoping for better quality amplifier, AC bias, all that kind of stuff, but I opened it up and find this little job in there, and I just laughed. I just thought that was funny. It's just your typical little 4-transistor. You can see it with the new caps on there. A lot of them red. Yep, you just got your 4 germanium PNP transistors. Pretty standard stuff for a recorder of this time period. A rim drive tape recorder. Very typical. Your input transformer, your output transformer. Pretty much as basic as it gets. Well, somewhere there's going to be a biasing resistor, and it's probably going to be in the kilo ohm range. And I have to figure out where it is in the circuit. I'll have to trace the circuit out. Of course, there's no way I'll ever find a schematic. I'll have to trace the circuit out and find where the DC voltage is managing to get it into the head. And it's usually not too hard to find. I'm going to go over on video the path that I found to finding the bias resistor. Since this is a DC bias recorder, biasing is extremely simple and done through a single fixed resistor. I look at the front side of the recorder and I see your record playback head goes to a shielded cable into the recorder. The shielded cable has the shield, which is connected to a red wire. That red wire simply goes to the ground. The other wire within the shield is going to be your signal wire. So I followed the signal wire from the head, which is right here. This gray one here is a shielded cable. It goes to an area on the record playback switch. In record mode, the head wire, which goes right here, can't really see it well, goes through the switch contact to this green wire. The green wire goes underneath the battery compartment. Grabbing a pair of tweezers and stretching the green wire a little bit makes it a bit easier to find where it goes on the circuit board. I pull on it, you can see it pulls this green wire right here. You can always confirm it with a continuity meter. So, I'll look at where the green wire goes on my circuit board. And it goes to this one track right here. Point it out easier. Green wire here goes to this track right here. Alright. The other side of the circuit board, I see that the track hooks up to the ceramic capacitor. It goes to the ceramic capacitor. And it also goes to this resistor. And it also goes to this resistor. This first resistor that I showed here ends up over here, which is in parallel with the ceramic capacitor, which then goes here, which is this electrolytic capacitor right here. That electrolytic capacitor then goes to part of the push-pull output of the amplifier before it goes to the transformer. So that's getting your audio signal out of the amplifier, going through this decoupling capacitor to get rid of any DC, then going through the ceramic capacitor in parallel with this resistor, then to the head. This resistor and capacitor parallel combination, I believe, is your pre-emphasis filter, which, because of the reactance of the capacitor being lower at higher frequencies, i.e. the capacitor's resistance is lower at higher frequencies, more high frequencies are allowed to go through than low frequencies, pre-emphasizing the treble during record to try to attain better sound quality. That's something that's done on all tape recorders, or normally done on all tape recorders, is you pre-emphasize the highs during record. That's normal. But where does the DC biasing come in? It's not through this resistor here, because this capacitor blocked any DC that might come out of the amplifier. Well, there's this other resistor that it hooked up to, a 25K. It hooks up to the head, and the other side of it goes to this longer track which goes to a bunch of stuff. Well, you'll see it goes to this blue wire, and I've traced the blue wire to the record, play, stop, rewind switch, and the different switching positions it goes to, you trace that out and you find it goes to your batteries. That's your power wire. This is your negative power wire, I believe, because this uses positive ground, and the ground, of course, is looped around the circuit board like this. So that's your negative power coming in, going into the resistor and going to your head. So that 25 kilo ohm resistor right here is the biasing resistor. So we're going to take that resistor out, and then we're going to check the voltage at the head during record to confirm that the bias voltage is not there anymore. Then we're going to see how the sound quality sounds in comparison to how it sounded with that resistor. Okay, I took the resistor out of the circuit board temporarily. We're going to put some connecting wires onto it so we can hook the substitution box to it. So we're going to hook it up to where some of the other component leads already are. Reason why I'm doing it like that is because these traces come off really freaking easily. It's a cheap circuit board, so the traces will lift off. They've been lifting off like crazy when I was replacing the capacitors, so it doesn't take much to lift these traces off. So if I solder them to where other component leads are, that will reinforce it a little bit, so it'll be harder to rip it off. Okay. Before we hook up the substitution box, we will confirm with this as an open circuit that we have no bias on the head. Okay, so we got the tape recorder here. We'll turn our meter onto the millivolt scale here, and we'll put the recorder into record position, and we will volume all the way down. We're going to go ahead, check this for voltage. There should be nothing there. Nothing. All of 0.1 millivolts. Zero. Nothing. Diddly squat. Zero bias. Nothing. Now, out of curiosity, let's see how it sounds with no bias at all. Flip it to this side. That's the side I was using. I don't want to record over precious recordings on the other side. Although the erase was not acting the most reliable, we may have to see about alignments and stuff like that. One of these days I'd like to build a magnetic flux detector. That would be good for checking heads and speaker magnets.
At a reasonable level. It also records at a weak level.
Okay. Stuff I'm recording over is just terrible recordings of country music, and I have absolutely no interest in country music, so especially if it's low quality speaker to microphone recordings of country music. So microphone jack is this one here. You need to get a different mic. This jack just doesn't want to stay plugged in for some reason. It's the sizing, the dimensions of the jack, the plug, and the dimensions of this recorder's actual jack aren't conducive to a slightly different length connector. You'll see these two different jacks are a little bit different from each other. Are you serious? The battery's already dead on my friggin' camera. Are you friggin' serious? Unbelievable. And now I gotta find my friggin' charger and plug in my dag-gone camera. Get the cord out of all this mess of wires and plug this monstrosity in. Camera is, well, now it's charging. I have a separate switch on the outlet. I had to turn that on. Okay, so we'll plug the microphone into the recorder. It's going to be a biasless recording. No AC, no DC, nothing. Hello, this is a biasless tape recording. There is no bias at all in this recording. It should sound absolutely, thoroughly distorted. The level is now set all the way up. The meter is being pegged. This is with zero bias, but due to the extremeness of the level, it is probably at least intelligible, albeit very, very distorted. Okay. Yeah, we're still having some trouble with this blowing thing. Okay. Why don't I put the thing back on? I was considering an idea, but I don't know if I want to do that. Okay, let's try this.
Hello? Hello, 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 hello. This is a reasonable record level. According to the level meter,
This is with the bias as it was originally.
assuming that it is accurate. But you'll notice the distortion is very strong, even at a reasonable level. It also records at a weak level.
Okay, this is going to get old. That freaking music on there. For some reason, it's just... I don't know if the erase head went open circuit or what, but it's just... It's not freaking erasing. The erase should be separate and not... Oh. Erase head's open circuit. I suspect it's the soldering joint there. It better be something like that, man. It's probably that soldering joint. It looks a little bit questionable. I'll touch that up real quick. We'll see if that fixes it at all. Because it was erasing before, at least to some extent. So, just going open like that is bad. Oh. Doesn't take much. I see it. The wire between the two coils has become disconnected. Got to locate the other side of that wire. Yeah, the wire between the erase head's coils has become disconnected. And here's the erase head. So very carefully access the other wire. Oh wow, that came out though. I think it's right here. Such a fragile. Is that the wire right there? I think it was like right there. It just did a little blip up like that. Probably won't connect at all doing it like this. No, not at all. Connected to this other side here. There's no way. Wire on the other side of that coil, it probably broke off right at the coil. Check the resistance. Wow. That's a shame. Especially when I see the meter register for a second, you can get your hopes up and then wow. I was a fool. Probably through taking the tape off, it broke the little wire at the top of the erase head. I managed to repair the wiring between the coils at the top, but my initial soldering of the bottom connection, I'm afraid, broke the wire. to one of the coils, and wire piece can nowhere be found, so I had to jump this coil here and go and only run 1/2 of the erase head. None of this excrement would have happened if I was so smart as to just have this top piece on the whole time. Probably me taking the tape off one time, the tape probably brushed against the connection on the erase head just slightly, and it's so easy to break. Such thin gauge wire right there. It's a problem waiting to happen. So for safety reasons, I want to put this piece on. We got that installed. At least it erases now, so yeah. You're only using 1/2 of the erase head, but it is still enough juice to erase. Hopefully not too much current is flowing to the erase head. So this, let's turn the level down. This is what it sounds like when there is no bias on a recording at all. No bias whatsoever. Not DC, not AC. Just direct audio to the head. Let's turn the level all the way up, and with the level all the way up, you'll probably be able to understand the words that are spoken, because any bias is what I would call self-biasing, biased by the audio itself, but it's not linear. So therefore it sounds distorted. Thankfully the erase is working, even only on 1/2 of the erase head windings are running. But anyway, and it's running at twice the voltage it normally would have. But I don't think it's 150 ohms. It's probably not going to be too bad. 6 volts on 150 ohms is probably not going to be the worst thing in the world. We're going to go ahead and try some different resistors. The original value was 25K. The closest we have on the substitution box is 22K. And so we're going to try different resistor values on the Yashicorder until we find one with better sound quality. So it looks so much cooler having the thing on anyway. So 22K bias resistor. This is a recording. Let's turn the level down some, turn it down, turn it down, turn it down. This is a recording with a biasing resistor of 22 kilo ohms. Bias resistor of 22 kilo ohms. This is a recording with a bias resistor of 10 kilo ohms. Probably too much bias, because I remember other recorders where I had to increase the resistance, i.e. lessen the bias. So we're going to go back to 22 kilo ohms. We're at 22 kilo ohms resistance now for the DC bias. Voltage is unknown because I am not measuring it. Now we're at 33 kilo ohms of DC bias. I know the level is a little bit high, but we should still be able to hear a huge difference in sound quality if there is any improvement in bias. Now we're running the resistance at 47 kilo ohms. Let's see how the sound quality sounds with the resistance of 47 kilo ohms. Okay. Now we're running it with a resistance of 68 kilo ohms. Probably getting too weak and having distortion by now. Now we're running it at 100 kilo ohms, probably way too weak and has distorted sound. Let's see how this comes out. I suspect the best value is either going to be 33 or 47 kilo ohms, based on experience with other recorders.
This is a recording. Let's turn the level down, some, turn it down, turn it down, turn it down. This is a recording with a biasing resistor of 22 kilo ohms. Bias resistor of 22 kilo ohms. This is a recording with a bias resistor of 10 kilo ohms. Probably too much bias, because I remember other recorders where I had to increase the I need less bias. So we're going to go back to 22 kilo ohms. We're at 22 kilo ohms resistance now for the DC bias. Voltage is unknown because I am not measuring it. Now we're at 33 kilo ohms of DC bias. I know the level is a little bit high, but we should still be able to hear a huge difference in sound quality.
You already could hear there was a definite difference. The speaker is rattling a bit. I'm going to try an external speaker, see if we get a better sounding with an external speaker hooked up to this tape recorder. Wow, it literally just sits in the... Wow, that's a... No, that's the external power jack. No wonder he was putting DC into the speaker, tapping it off the batteries. It's a bigger size jack. That's interesting. That's a weird size jack. Holy crap.
We're at 22 kilo ohms resistance now for the DC bias. Voltage is unknown because I am not measuring it. Now we're at 33 kilo ohms of DC bias. I know the level is a little bit high, but we should still be able to hear a huge difference in sound quality if there is any improvement in bias. Now we're running the resistance at 47 kilo ohms. Let's see how the sound quality sounds at the resistance of 47 kilo ohms, okay? Now we're running it with a resistance of 68 kilo ohms, probably getting too weak and having distortion by now. Now we're running it at 100 kilo ohms, probably way too weak and has distorted sound. Let's see how this comes out. I suspect the best value is either going to be 33 or 47 kilo ohms, based on experience with other recorders.
Now there's a bit of DC bias, yes, but you could already hear improvement. This doesn't monitor by recording, I have found. So we're running it with 47 kilo ohms, 47 kilo ohms, 33 kilo ohms. Yo, boom! 33 kilo ohms, 33 kilo ohms, 47 kilo ohms, 47 kilo ohms, 47 kilo ohms, 33 kilo ohms, 33 kilo ohms, 47 kilo ohms, 47 kilo ohms, 33 kilo ohms, 33 kilo ohms. Alright. Probably going to go with 47.
I suspect the best value is either going to be 33 or 47 kilo ohms, based on experience with other recorders. This doesn't monitor while recording, I have found. So we're running it with 47 kilo ohms, 47 kilo ohms, 33 kilo ohms, boom, 33 kilo ohms, 33 kilo ohms, 47 kilo ohms, 47 kilo ohms, 47 kilo ohms, 33 kilo ohms, 33 kilo ohms, 47 kilo ohms, 47 kilo ohms, 33 kilo ohms, 33 kilo ohms. Alright.
I want to try 220K out of curiosity. 220 kilo ohms. Testing 1, 2, 3 with a high recording level. Regular, better recording level with a 220K ohm resistor.
We're 43 kiloohms, 47 kiloohms, 47 kiloohms, 33 kiloohms, 33 kiloohms. Power. 220 kiloohms. Testing 1, 2, 3 with a high recording level. Regular, better recording level with a 220K ohm resistor.
No. That's bad. Okay. This standoff is between 33 and 47. 33, 47. Last battle. We're going to try music.
33, 47. Last battle.
Now 68. Well, maybe I'll choose a compromised value. I'll go with a 39K. We'll use a 39 kilo ohm. $39K is going to be my resistor. As they say, resistance is futile. Thought I took the screw off, dang it. Got the futility in there. And we're going to solder the futility in place. And take a good look at that. Yeah. Pretty cool, eh? Yeah, beep. All that silly stuff I do on purpose. Saying yo boom, going. All of it, man. Do it for two reasons. Reason A, kicks. Reason B, giggles. Come on, screw. Get on there. Before rewind, we're just, yeah, whatever. The grum. It's enough. It's enough power to rewind. We're going to leave the rewind, I think, alone. But I want to go ahead and clean the drive for the play. See if we can get, for what it's worth, better speed stability on here. Of course, I still have the tape in there, so that's going to be good in one direction only. I'm using Windex ammonia-based Windex. It seems to do well for cleaning rubber. We're going to do one more pass. Maybe the rewinding can be cleaned a little bit. Go into rewind mode. We can clean the spindle for the take-up drive. We use isopropyl alcohol for that. The rubber for the rewinding is literally just disintegrating and falling apart. It's just no good. But it still has enough drive to rewind it that at least it is able to rewind at all. So I'm going to dry off the Windex from the take-up reel drive. That should improve the take-up's torque, I hope. It should. Yeah, I think the torque is a bit better now. Well, now we'll put the back onto the YC-25. And we'll put the YC-25 in its leather case. Soldering equipment is all turned off. I mean, the build quality, man. You got, aside from the plastic for the top part with the reels, you got an all-metal case, even the metal back. The transport mechanism is very solidly constructed with surprisingly thick, strong metal and precision machine parts. You got a good quality motor in there, and then you got this silly little little 4 transistor job, DC bias, you know. Though it is rim drive, and ironically well built for rim drive, it's unusual. One of the charms of this recorder, really. That's the same reason why, similar reason why I bought the Yashicorder 89. Of course, the Yashicorder 89 is AC bias and rim drive, which is a very unusual combination. The rim drive machines that are more well made, using flywheels and actual governor controlled regular type higher quality motors and whatnot, are oddballs amongst the recorders and not seen very often. And the cost that it takes for making the rim drive mechanism in this recorder is probably similar to the cost it would for a capstan mechanism, and that's always what makes me curious as to why they would go for rim drive in the first place. Except maybe they wanted to make it compatible with other rim drive recorders. Except these ones don't have speed controls. It's a single speed. Of course, you have a constant angular velocity with rim drive versus constant linear velocity with capstan drive. Now, this recorder from May 11th, 1965 can proudly be put into its leather case. Having some issues here. Battery door or something is catching. There we go. Come on, YC. Get in there. There we go. And the YC-25 is installed into its case. Pretty cool looking tape recorder. Which side was I using? So I have to go to bed. But anyway, okay, now that it's together, we'll make a voice recording on it. And hopefully biasing is good. This is a recording on the YC-25 reel-to-reel tape recorder, now back in its case with a biasing resistor of 39 kilo ohms. This is a recording on the YC-25 reel-to-reel tape recorder, now back in its case with a biasing resistor of 39 kilo ohms. Surprised by how much motor noise there is in the recording, considering the fact that the battery and amplifier are powered separately. But at least sound quality wise, aside from your typical DC bias S, it actually doesn't sound all that bad. Quite something. Okay.
All of this stuff is related.
Yeah.
The ability to see purpose and design in life was thrown out by Darwin's theory. And it ultimately leads to denying humanity, denying anything exists beyond the physical level.
Okay, but what I find interesting is those scientists never really come out and say that, because that would be so unpopular, you know, the mobs would come for them.
Oh, they do say that.
Well, but they don't say it publicly. They're not going to say it to a Time magazine reporter, generic Time. They understand that it's, first of all, very ridiculous, but it's also, even if people buy it, it just feels wrong, like it feels mistaken. And they don't seem to be pushing that idea.
That's right. I think they're kind of screened by the media, who will see how it will be perceived as, you know, really ridiculous.
So, definitely acceptable sound quality now. Even though you still have the DC bias sibilance, notice that when I was trying different resistors, no matter what value you chose, you always were dealing with that DC bias sibilance. That I think is more from pre-emphasis.
Ability to see purpose and design in life was thrown out by Darwin's theory. And it ultimately leads to denying humanity, denying anything exists beyond the physical level.
Okay, but what I find interesting is those scientists never really come out and say that, because that would be so unpopular. You know, the mobs would come for them.
Oh, they do say that.
Well, but they don't say it publicly. They're not going to say it to a Time magazine reporter, generic Time. They understand that it's, first of all, very ridiculous, but it's also, even if people buy it, it just feels wrong. Like, it feels mistaken. And they don't seem to be pushing that idea.
That's right. I think they're kind of screened by the media, who will see how it will be perceived as, you know, really ridiculous.
With the bias resistor set, aside from DC bias S, it has a decently full sound coming from its speaker, which for a lot of those 4 transistor amplifiers don't always perform that well in that respect. So I'm pleased with that particular way to it. So definitely an interesting recorder. I'm going to try, through the professional microphone setup I have, I'm going to try de-essing my speech and recording it that way. See how it comes out.
What's up, man? What's going on? What's going on, G? What's up, man? Welcome to the stream. Okay, we want to de-ess this like mad. So we're de-essing big time. De-ess. We're de-essing this big time. We want to really de-ess the sound here. We want to de-ess this like a madman. We want to de-ess this good. Hello there, testing 1, 2, 3. With heavy about a de-essing in the sound. It's 9:27 p.m. and I need to be to bed. Oh, good grief. Of course, I got 2 more days of work this week. Testing 1, 2, 3. This is the Yashica Yashicorder YC-25. DC bias.
DC bias. DC bias. Need battery access. There you go. Ooh, my motor. For what it is, it's not too bad with the sound. Speed stability, although it is a bit sensitive with the orientation of the recorder. I guess gravity is affecting how hard that's pushing up against the take-up reel drive. But aside from that, though, it's surprisingly stable speed-wise for music because of the flywheel and the governor-controlled motor. It's just a better system than most rim drive recorders are. It's definitely a better rim drive. I want to play, before I go to bed, I'm going to play this through an external amplifier. Just I'm curious how it plays back. Of course, really the best test is to play it on another machine, but then you're probably going to have speed issues between two different machines, because rim drive. So, yeah. No bass at all. Turn the bass up. Safety. Safety. Quite something, am I right?